All right, so in this video, we're going to go through the Society of Actuaries sample question 29 from their ExamP list of sample questions. The question reads, the number of days that elapse between the beginning of a calendar year and the moment a high-risk driver is involved in an accident is exponentially distributed. An insurance company expects that 30% of high-risk drivers will be involved in an accident during the first 50 days of the calendar year. What we need to do is calculate the portion of high-risk drivers that are expected to be involved in an accident during the first 80 days of the calendar year. So what do we need to know in order to start the question? First, you should be familiar with obviously an exponential distribution. Okay. Now, the exponential distribution, the parameters for it differ depending on kind of where you're learning it from, right? Some people might learn that the expected value of an exponential distribution is theta, and that's what I prefer, while other people might see it as being 1 over lambda. All right, I'm going to use theta for this problem. However, it should be stated that theta is equal to 1 over lambda. All right, so now it says we have an exponential distribution. Right? And it tells us that an insurance company expects 30% of high-risk drivers will be involved in an accident during the first 50 days. So that's telling us that the probability that you have an accident, right? So X is the event of having, number of days since the beginning of the calendar year of having an accident. The probability that that's less than or equal to 50 is equal to 0.3. Okay. Now it's a very, very good idea to memorize what the CDF, the cumulative distribution function, is for an exponential random variable. An exponential random variable is a continuous distribution that has the following formula. So this would imply that 1 minus e to the negative x, in this case x is 50, over theta is equal to 0.3. Now, if you are used to using this definition of lambda instead of theta as your parameter, it would have been 1 minus e to the negative lambda x. Okay, just to make that clear. So 1 minus e to the negative 50 over theta is equal to 0.3. And right now our job is to get theta, right? If we can figure out that parameter, we're going to be able to then figure out what the question's asking us, which is that the probability of an accident occurring within the first 80 days. There we go, within the first 80 days. All right, otherwise we're not going to be able to actually fill in a theta value for our equation. So let's just go about solving this, right? At this point, this is algebra. So I subtract 1 to both sides, and I divide by 1. So that's 0.3 minus 1. And I'll divide by 1, and that's 0.7. So e to the negative 50 over theta is equal to 0.7. And then I have to take the natural log of both sides. So ln. That'll cancel, and I have negative 50 over theta is equal to the natural logarithm of 0.7. And then I isolate my theta, and I get negative 50 divided by the natural logarithm of 0.7 is equal to theta. Right? And just to make this easier on myself when doing the calculations, what I like to do, and this is just kind of more of a tip than, a probability thing, it's a calculator thing, I'll do negative 50 divided by natural log of 0.07, and I'll store that as x, right? Just so it's easy for me to input in later. It'll make things faster for you. I'm saying that for a reason, right? So we want to find the following: the probability that x is less than or equal to 80. And that's going to be 1 minus, like stated before, here's the equation for the cumulative distribution. E to the negative x over theta, where x is 80, right? 1 minus e to the negative 80 over theta, which in this case, I'll write it out as such. Let me just extend that and put these in parentheses just to be clear. Negative 50 divided by the natural log of 0.7. Okay, now that is something I can just put into my calculator. So 1 minus e raised to the negative 80 over, negative 50 over natural log of 0.7, which I denoted before as x in my calculator, so that's all I have to put in. All right, sorry about that weird cut. I think my camera ran out of batteries, but I think the last thing I think recorded was the fact that I have this equation here, right? I typed that into my calculator in order to get the following 0.4348. All the answer choices are rounded to 2 decimal places. So it looks like it's going to be approximately 0.43 as my final answer, which lines up with answer choice C. Okay, so what can we take away from this problem? The problem asks about the CDF. Now, for all the continuous distributions that you need to memorize, this goes for continuous uniform and gamma distribution, although gamma is very rarely on, and normal distribution, obviously. Knowing the CDF, super important, right? A lot of people might not, you might see some books not talk about memorizing the CDF, just the PDF, because technically you should be able to derive the CDF by integrating the PDF, but it's much more helpful and much quicker just to have this memorized. So the cumulative distribution function for an exponential random variable is the following: 1 minus e raised to the negative x over theta, where theta is the expected value. And this problem was just using an exponential distribution. And if there are any questions, you can leave it down in the comments. I'll answer to the best of my abilities. Hopefully this video helped you out. If it did, hit the like button, subscribe, because that totally helps me out. All right. If you want to see some more videos of worked out problems, I have a playlist. Check that out. But other than that, good luck, guys.